Students, welcome back. We're starting a new unit today. We'll be looking at exponents and some of their properties. So today we'll focus on what an exponent and that expression is, and then the multiplication and the power properties. So when you speak of an exponential expression, you have a base. In this case, this is the x. Then in this expression, you have an exponent. In this case, it's an n. And then the whole expression together is known as a power. So if I have 4 to the third power, the meaning of that is that I would be taking the base of 4 times itself, the number of times that is given in the exponent. So 3 times. And then 4 times 4 times 4 is equal to 64. Now, negatives with exponents work like this. If you have a negative outside of a exponential expression, then the negative will stay, and your base, which in this case is the 3, will be multiplied by itself, the exponent number of times, so 2 times. And that means my negative that is outside the parentheses will be in my answer, -9. But in the case of this second problem, my base is actually including the negative because it's inside the parentheses. So the -3 will be multiplied by itself the 2 times that the exponent says, and a -3 times a -3 is a +9. So it does make a difference whether or not you use the parentheses. If the parentheses are there, the negative gets multiplied right along with the base. If the parentheses are not there, the negative stays outside and only the base gets multiplied. So we're going to pick up on our first exponent rule, and this is if you are multiplying powers. So notice that the bases have to be the same for this rule. If you are multiplying powers, then the exponents add. So when you multiply the same base, you are to add the exponents. Add the exponents. Notice also that you would keep the base. So that's in addition to working with the exponents. Keep the base. All right, so at the beginning of your assignment, you're going to have a question that asks you to write this without exponents and then to write it with. So we're going to do that on this first example. Writing it without exponents, y to the 4th means y times y times y times y. Y to the 5th means y times y times y times y times y. And so that would be writing it without the exponents. Or you could do this by adding the exponents together. So the 4 plus the 5 to give you y to the 9th power. Your second problem still is going to involve multiplication of powers, but this problem has coefficients. The -4 and the 3 are not exponents. They are the coefficients, the numbers in front of your variables, so they can be multiplied together. But then your powers are the a to the 2nd times the a to the 4th. So we can multiply together the -4 and 3 to get -12. And then for the a, we can add together those exponents so that our final answer would be negative 12a to the 6th power. All right, as we move on to your second one, we have a power to a power. This is another rule. We have a power of a power. So if you have an exponent outside the parentheses, such as what we have here, a power raised to a power, we will multiply the exponents. So multiply the exponents. Again, keeping the base. And so our next example, we have 2 to the 3rd to the 2nd power. So our base of 2 will stay. Our exponents of 3 and 2 will multiply together. So we'll have our base 2 and our exponent will be to the 6th. And I might just add that as you're writing something as an exponent, make sure that you have that exponent as a superscript. It is not to be on the same line. It's not to look like this negative 12 does. It needs to be written as lifted up. It's a superscript. Okay, problem number 4. Your base is x, and then your exponents are the 5 and the 3. So they will multiply together. And our final answer for this one again will be x, and then your exponent would be 15. So this is when you have parentheses with a power on the inside and a power on the outside. Multiply those exponents. Now that leads itself to when you have the power of a product. When you have that, you'll need to distribute. So we're going to distribute the exponents to each factor inside the parentheses. So each factor inside the parentheses will be raised to that outside exponent power of m in this case. All right, so in the case of this one, we have 4xy as our base, all of it inside the parentheses to the 3rd power. So that means that our base 4 will be to the 3rd power. Our base x will also be raised to the 3rd power, and our base of y will also be raised to the 3rd power. So the 3 power will distribute to each factor. And then the 4 to the 3rd power, we can simplify. Now, I'll go ahead and show you on Desmos. You can do this. You can be on the graphing or on the other Desmos. 4, and then use your shift 6 and go to the 3rd power, and there's your 64. So 4 to the 3rd power giving you 64. And I'll go ahead and write that. We will go ahead, unless it says otherwise, and simplify our number expressions. So 64, the x will keep the exponent 3, and the y will keep the exponent of 3. Okay, problem number 6. You have noticed that we have a negative inside the parentheses. So that negative 3 is the base, and our exponent outside is this 4. So negative 3 will be to the 4th power. Then a, now it already had an exponent of 5. That 5 will multiply by the 4. And then our base of b, which had an exponent of 6, will multiply by the 4th power. So I'll show you in Desmos, that -3 to the 4th power, when I type it in, I want you to see that you'll have two different answers if you don't use the parentheses. So here's the correct answer with the parentheses, raising it to the 4th power, you'll get 81. If you don't put the parentheses in, then notice that you do get a different answer, and this one is not correct. So you would not get the correct answer, and you would need to use the parentheses to get the correct one. So 81 positive is the correct answer for this because we needed the parentheses. So this is 81, and then A would be to the 20th power and B to the 24th power. And then we're going to just do a couple of examples where you need to simplify the expression. If you have a fraction, you still want to treat it like our rule where we are distributing. It's just that you'll distribute this outside exponent to the numerator and the denominator, all the factors. So we'll start with our numerator of 2, and that will get the exponent 2. Your x that's in the numerator will also have the exponent of 2. Then your denominator, so make your fraction bar. Denominator has a 3. That 3 will have an exponent of 2. And then the y, which already has an exponent of 4, that 4 will multiply by the outside exponent 2. So be sure you keep things in place where they are as a fraction. So 2 to the 2nd power is 4, and then you have x to the 2nd. That's in your numerator. In your denominator, 3 to the 2nd, that's 3 times 3, that's 9. And then your y, 4 times 2 is 8. And that would be your simplified expression. And then finally, you have example number 8. And so you have a parentheses with a power outside multiplied by another parentheses with a power outside. So we always want to remove the parentheses by distributing the power. So this power 3 is going to distribute like this. You'll have your 2 with its power of 3. The m, which already had an exponent of 2, and that 2 will multiply by the 3 that's outside the parentheses, and then the n, which already had an exponent of 3, will also multiply by that outside exponent 3. Then we'll move on. We'll remove this parentheses. I'll use a different color for that one. I'll use blue. So you have your base of 3, and its exponent will be this outside 4. The m, which already had an exponent of 3, that will multiply by the 4. And then finally the n, and its exponent will be the 4. So notice what I've written in pink, the 3 distributed, and what I wrote in blue, the 4 distributed. So your 2 to the 3rd, if you need to, you can use Desmos for that. It's 2 times 2 times 2. That's 8. And then we have m to the 6th power, n to the 9th power. We're multiplying that by, and then 3 to the 4th. Again, you can use Desmos if you need it. It's 3 times 3, which is 9, and another 3 times 3, which is another 9. 9 times 9, 81. 3 to the 4th is 81. And then you'll have m, this is to the 12th power, and your n to the 4th. Now, what we'll do is multiply together the coefficients 8 and 81. So 8 will multiply by 81. Then for your bases that are the same, for the m's, these exponents will add. So we'll add together the 6 and the 12 for the m. And then for the n, we'll add together those bases, those exponents. And so we have the 9 and the 4 that we'll add together. Notice, though, that I'm not adding the bases. The bases are all multiplied. So 8 times 81 would be 648. And then my m is to the 18th power, and my n is to the 13th power. So there's no plus sign in that final answer. The only plus sign in the problem was when I added the like exponents. Rather than writing out 6m's and 12m's, rather than writing out 18m's, I just added those exponents together. I did the same thing for the n. So your assignment will be on Alex. Make sure you ask questions as you have them. Good luck with your homework.